In this lesson we are going to learn about magnetic materials. Okay, before that let's learn some basic concepts so that we can easily learn about the magnetic materials in terms of their properties. Okay, so you must be knowing that magnetism or magnetic field is caused by moving charges. Okay, so we are especially concerned about electrons. Okay, so you know electrons, they tend to orbit around your nucleus. Okay, so since electron is orbiting, it is moving, right? So you are going to have magnetic field due to that. Apart from that, electron also has its intrinsic spin. Okay, so just like Earth, it revolves around the sun and it rotates along its axis as well. You can roughly think of your electron revolving around your nucleus and spinning along its axis as well. Okay, so this spinning also results in creation of magnetic field. Okay, so you can say that when we are talking about electrons, there are two forces or two mechanisms through which your magnetism is being created or your magnetic fields are being created. One is due to your orbital motion, okay, and other is due to your spin motion. Okay, so if you remember, in dielectrics we learn their properties in terms of my electrical dipole moment, right? So similarly in magnetic materials we are going to understand their properties by a similar concept which is known as magnetic dipole moment. Okay, so if you consider a magnet, okay, we know magnet has a north pole and a south pole. Okay, so let's just say I have a magnet over here. It has a south pole, it has a north pole. Then your magnetic dipole moment due to this magnet given by mu is simply product of your pole strength, okay, into the vector joining south to north, okay, into L. Okay, L is a vector from south pole towards your north pole. Okay, so your magnetic moment also has a direction from south towards north. Just like if you talk about a equal and opposite charges, then electrical moment is a vector from negative charge to positive charge. Okay, so the same concept over here, you can think of your negative charge as your south pole. Okay, so your magnetic dipole moment is from south to north. Okay, and we know magnetic fields are from north to south. Okay, just like your electric fields are from positive to negative. Okay, so you can just have an analogy where you can just assume your negative charge to be your south pole and your positive charge to be your north pole, and just have the similar concepts transported to your magnetism. Okay, so the moment is from negative to positive, that is south to north, and field is from north to south, that is positive to negative. Okay, so when we talk about electrons which are having an orbital motion as well as a spin motion, each of these motion corresponds to a magnetic moment, and your net magnetic moment of your electron is the addition of both of these spin as well as orbital magnetic moment. Okay, if you have a current which is going like this, okay, in a circular closed loop, then this current also produces a magnetic dipole moment. Okay, the value of this magnetic dipole moment is equal to your current into your area, okay, which is the area of this loop. Okay, and the direction is given by your right hand rule. Okay, what is your right hand rule? You simply curl your right hand